Okay. So today, not a big wild challenge, but from pre-calculus, please note the arrows poorly drawn on both ends. Identify all the maximums and minimums. So Luke, what do you think? Where's a maximum?
Negative 2.7, 2.1.
Okay. I'm asking for the value of the maximum. Is it the whole coordinate?
2.1.
Jasper, would you think, is that a local or an absolute maximum? Local. How can you tell? Because there's y values higher than that over here. Okay. Gus, what do you think about minimums?
Negative 3.
The y value, and is it local or absolute? Local. Okay. What does it take to be an absolute max or an absolute min?
Well, it depends on the highest or lowest point on the graph. Period.
Okay, it needs to be the highest or lowest point on the graph, period. Do I have a highest or lowest point on the graph, period? No. So from pre-cal last year, we did stress this as well. There are no absolute maximums, no absolute minimums, because they want a value. Tell me the value. And if the value is infinity, that's not like, I want a number. And if you ever pick a number, I'm gonna add one to whatever you said. So this doesn't have an absolute, but there are locals. And here's the catch with AP. Did they ask, when did this reach the maximum, or what is the maximum? If they ask, when was the high temperature of the day? Oh, 2 p.m. What was the high temperature of the day? 72 degrees. Like, there's a difference, and it's subtle. Yes?
In terms of the no absolutes, what if you have like a parabola and it's
Okay, so that's actually the lesson today. If right here, I swear I'm drawing. Wrong color. All that to make it go away. So if I change my graph and I chop it off, now do I have an absolute maximum?
Yeah?
Yeah, it would be whatever this y value is. Do I have an absolute minimum?
Yes.
Yes, it would be this negative 3.45. What is this guy?
This is the edit point.
Well, Sydney, what were you gonna say?
Would it be a local minimum?
It's a local minimum, because it's the lowest in, like, looking around, he's the lowest value in his area, but there are lower spots here.
This area? What?
Like, if you were standing right here, looking to your right, you ain't got nobody there. Looking to your left, they're all taller than you. It's like the story of my life. Everybody's taller. So this one is the lowest compared to everything around it. Here's another question. That's now an open hole. Is that a maximum?
No.
Is there an absolute maximum in the graph anymore?
No.
No. Because you get really, really close to it, but I'm gonna demand that Camden actually gives me the y value. And whatever he's like, well, we get really, really, really close to 3.5. Well, what, 3.49? Well, I'm gonna add a couple extra nines at the end of that, and he's not gonna be able to say the maximum. This one is a local maximum, but still there's y values higher over here. Okay, so that's basically the whole lesson of today. We're going to identify what is an absolute and a local extreme values and when they're guaranteed to happen. I don't know that you need to write this down. Look at the words. This is math speak defining what maximum and defining what minimum is. Whoa, I shut down again. Awesome. Hello, come back up. Okay, so sorry. Root recalculation. Yeah, that would be good. Okay. So they're defining absolute maximum to be, and it's the y value is the absolute maximum. If this y value is bigger than or equal to every other y value, and y or equal, writing in white. If it's a sine and cosine function, do I have an absolute maximum? Lots of them, and they're all the same value of 1. Do I have an absolute minimum? Lots of them, and they're all -1. So you can have several absolutes. They could happen in multiple places, and they have to all have the same y value. Absolute minimum, again, it's the y value, and that's to say it's the lowest y value of all the y values at wherever y values. So not wild and crazy, but here's the gross technical definition. All good? So they're saying for all x's in the domain, this f of c, this specific one, is the lowest y value of everybody. Can I turn the page, or you guys wanting to write it? Some people are wanting to write it, so I will wait. Let me know.
Okay, I'm done.
All right. So we just talked about this one. Someone had mentioned parabola. So this one, the parabola is going forever up. So there's no absolute maximum. But there is an absolute minimum. The absolute minimum is the y value of 0. Cool? Okay, now we're going to chop part of it off. Now it's a closed dot here and a closed dot there. The absolute maximum is 4. The absolute minimum is 0, right? Because we chopped the domain and said just this snapshot. Now with an open hole there, no absolute minimum, but there is an absolute maximum. Cool. And then if they're both open, no absolutes. Simple enough? Didn't?
Can there still be locals?
Sure. So okay. And also, are any of you swimmers in here? Katie Ledecky, locally she happens to be the fastest swimmer. Also globally, she's the fastest swimmer by pool lengths. So your local could also be an absolute, okay? All right, so you should write this sentence down. If you have a closed interval, so meaning the endpoints are included, and it's continuous, you're guaranteed to have a maximum, and you're guaranteed to have a minimum. Absolute. Okay, so this is like if I declare we're gonna have a race and everyone needs to play. One of you will be the fastest person, and one of us, maybe me, will be the slowest. Like you're guaranteed to have someone that's fastest and someone that's slowest. You're guaranteed to have someone that's tallest and someone that's shortest. And it depends on how you line people up, but maybe that maximum happened in the squishy middle and the minimum happened in the squishy middle. Or maybe I made you line up tallest to shortest and the maximum was the first person, the minimum was the last person. Or like, so this is a picture of each possibility. Clearly, when it's a picture, it's easy to do. But if I said this, what's the absolute maximum from -3 to 5? Well, you kind of have an idea that it's a cubic and it's going to do something like this, but where in that range is it here? Is it there? Like, you need to do some analysis of the function, and that's the calculus of this. We're going to look at these. Yeah.
Don't you find the zeros of the derivative?
So we haven't done this yet. So this,
Okay.
yes, sir. Okay, this is in your textbook. If you really want to draw the picture, look at the textbook. But what Ethan just said, don't those maximums and minimums, don't you want to take the derivative and find where it's 0? 0 or what's the
Yeah.
slope right there?
Oh, undefined.
So the maximums and minimums, they don't have to happen here, but if they're going to happen, it's when the first derivative is 0 or undefined, an extreme may happen. It's not guaranteed. Ethan, can you do the spoiler alert? What do you have to check to guarantee that it is one?
You have to plug in the point.
Plug in what point and into what?
The x value of the 0 into the original equation. No. I don't remember.
Okay. If this blue thing is my function, I'm going to get zeros in my derivative here and here, and this is going to be an undefined. Luke, what is the value? Oh, Ethan, do you know?
No.
No.
You have to plug in every point possible, even the endpoints. So like the endpoints, any points where it's 0, and any points where it's undefined.
Okay. All right. So we'll look at some of these, but here the first derivative is it positive or negative? Positive. And here the first derivative positive or negative?
Negative.
So when the first derivative turns from being positive, the slope stops going up and starts going down. That's guaranteed to be a maximum. I don't know if it's absolute or local. Nick was saying how to determine what flavor it is. So I don't know which kind it is, but I know it's going to be some kind of maximum. And here, when the slope stops being negative and starts being positive, like you're tanking, it's looking bad, it's horrible, you hit rock bottom, and thank God it finally turns around and life is getting sunny again. You hit your minimum, and then it bounces back. It's guaranteed to be some kind of minimum when the slope stops being negative and starts being positive. All right. So let's look at this. Critical points. It's important that you know the definition of a critical point. They ask for them all the time. Definition of a critical point is anywhere in a derivative that the first derivative is 0 or does not exist. It's both of those. So for the function that's up here, do the derivative and find the critical points.
If you want to.
Okay, so Brooke, how do we find critical points with this function?
I found the derivative and then I set that to 0.
Okay, so doing the derivative, what do we get?
2x squared minus x minus 6.
And you said set it to, where is it undefined? Nowhere? Okay. Camden, how do I factor this?
I didn't get there yet. I guess it's 2x squared minus 4x, and then the other ones.
2x, are you splitting the middle term thing?
And then b like plus 3x, so it would be
Okay.
2x and 3, or like x.
All right, so I'm gonna introduce you guys to factoring by Zen, is what I was taught. You kind of get a feel for it. And even though this is AP, normally it's gonna factor because we want nicer numbers. If this is gonna factor nicely, two things that multiply to be 2x squared, it's gotta be 2x and x. All right, this one's kind of harder. Things that multiply to be 6, 6 and 1, 3 and 2, that I want the difference of them, the oily part of FOIL to come out to just be 1. I'm kind of thinking a 3 here and a 2 there so I can get 4x and 3x. And I want them to subtract to be negative, so that one's going to be a negative and that's positive. Factoring by Zen. You just see it. Because that's splitting the middle term, and I absolutely hate it. However, that is a very clear-cut method, and it works. I just hate it. So if that's your preference, feel free. Okay, so, but factoring now, these are critical points. That's the definition of it. The first derivative was 0 or undefined at these points. It's critical points.
So like on the graph, that's just when it does this. So like it's just like the vertex when it does that.
Okay, it could be.
Oh, it could be
So-
just other ways.
Well, there's other things that can happen, and we'll show those in a second. So I'm gonna just check the number line to test that things do what you just said it does. Okay, number line. I'm gonna pick like negative 100. What am I plugging negative 100 in? Sasha, am I plugging into the original function or the derivative?
The original?
The derivative, because I want to know, is the function increasing or is the function decreasing? So I'm gonna put in negative 100 into my derivative, I'm gonna put it into the factor thing. I don't need the exact value, I just need to know if it's positive or negative. So putting in a negative 100 times a negative something else, overall that's gonna end up positive, right? Testing a number in this range, like 0, I get positive 3 and negative 2 overall. I don't care that it's negative 6, I just care that it's negative. And then picking 18 million, they're both gonna be positive. So already now I know the slope is increasing till here, and then it starts decreasing till there, and then it goes up. And I didn't put any kind of restriction on this, so there is no absolute maximum, there is no absolute minimum, but I know the local is going to occur at x equals negative 3/2, and the minimum is going to occur at 2. Do I know what the absolute minimum is yet? Or local minimum? No. So I don't know, I know the x values, I know the times when they happen, but I don't know the values. If I make a restriction and now I'm gonna tell you, you know what, it doesn't go forever. I wanna just check from negative 3 to 4, am I guaranteed an absolute max and an absolute min now? Yes, because it's continuous and it's closed, so there has to be one of those. And Nick, how did you say earlier that we would find what those were? What do we do?
You have to plug in the critical points and the endpoints to the original to determine their y value.
So we just said, you have to plug them in. Plug in the x values now. Now, Preston, do I plug them into the original function or the derivative?
Original.
The original, for this one, I'm not asking, is the function moving up or is the function moving down? I wanna know the actual y values. So I would plug in negative 3 and I would plug in negative 3/2. And doing that at negative 3, I'm undefined. At negative 3, it's 2.5. And negative 3.5, this is our, negative 3.5 is 12.625. And 2 looks like a nice number, looks like negative 4/3. Yeah.
Are you plugging into the derivative or the reciprocal?
Preston, what am I plugging it into?
Original.
Original. Because I want to know the y values. So those are about the values. So now what's the absolute maximum?
Absolute maximum. There is no absolute maximum because there's no restrictions on the domain.
I changed the problem. You're right, originally there wasn't any. So,
It's,
but now I've changed it. I am restricting it and it's closed. I'm including the endpoints. So looking at the y values in the table, y values from the original function, now that, so Nick said, put in the critical points and the endpoints and find all those y values from the original function, and then you just look, who's the highest one? The absolute maximum is about 17.4. When did it happen? At the endpoint of 4. Where's the absolute minimum? The absolute minimum is negative 4/3. Where does it happen? At x equals 2. Okay. Find the critical points. So Ari, we're here for the definition of a critical point.
I'm assuming it's when you make you find the derivative and you say equal to 0.
Okay,
It's when like the slope equals 0.
Abby, what's the extra bit? He said, I'm assuming, but
Oh, but it can also when it doesn't exist.
when the first derivative is 0 or undefined.
It's constantly increasing it, so there's no local or absolute minimums or maximums.
So the critical point is at 0, and as Amir just said, all right, critical point was 0, and it's still a critical point. Like, by the definition, the first derivative was 0 there, it's a critical point. Okay, but if I didn't have a graph and I wasn't thinking at all, just panic, I'm gonna test my number line of the first derivative. Some negative 18. Negative 18 squared became positive times 3, it was positive. Then putting in 9 million, putting that in, it's still positive, and as Amir said, the function is constantly increasing the whole time, no critical, or sorry, it is not a maximum and it's not a minimum. Those of you who did the optional delta math with calculator stuff, do you remember what they called that?
Inflection.
An inflection point.
I didn't get calculator stuff.
So it's when it's, oh, do you remember from pre-cal what curving that way is called?
Concave down.
Concave down, reach it around. And this part is concave up. Inflection points happen when the curviness of the function changes. Okay. So this one, critical point. Eitan, how do we do the derivative of this one?
Power rule.
Power rule, okay. Doing power rule, what do we get?
1/3 x to the negative 2/3.
So first derivative is not 0 anywhere, but Jamie, where is it undefined?
It's 0.
So this is a critical point. X equals 0 is a critical point. But Amir, what do we know about the function?
It doesn't exist as 0.
The function exists, the derivative doesn't.
Oh yeah, the derivative. I understand that.
And again, if I'm not thinking about it, I'm gonna test the number line, putting negative 100 into the derivative, because I wanna know, do I have a maximum? Does the derivative go from positive to negative? Does the slope stop going positive and start going negative? Do I have a maximum there? Putting it into here, putting in that negative 100, it got squared and became positive. Oh, so that's gonna be always positive. So is that, so again, it's an inflection point. It went from being concave up to concave down. It's still a critical point.
Where's a situation where an undefined point would be an extrema? Because it can't ever, like, why are they still considered critical points if, like, they can't flip when it's a customer node?
And birdie. So right there, that is an absolute minimum. Good question. I think it's on the next slide. Oh, it's not. So anyway, this one, I mean, what's the derivative of y equals x to the 2/3?
2/3, 2 and 3x.
So x equals 0 is a critical point in this one also. Sorry, what?
dy did I miss something? Why the dy dy? Oh, okay. I mixed more than
Okay, And why does this say pi? I don't know. So this one, plugging in a negative number, cube root of a negative, Miriam, what's the cube root of a negative? Is it positive or negative, or do you not know? Like the cube root of -8.
Well, is it not imaginary?
Cube root, can 3 numbers multiply to be a negative? 3 of the same number. Yeah.
Yes.
So -1 times -1 times -1 is still negative. So on this side it's negative, on that side it's positive. So the slope is going down till it hits 0, and then the slope is going up. So that means it's a local minimum, but do I have any other critical points? So I know actually that it's an absolute minimum because it's forever coming down till here, and then it's forever going up. Why do I know that it doesn't change anywhere else? Because there's no other critical points. Critical points mean it's changing from one thing to another. All right. So I don't know that you need to write all these things down, but we're getting into applications of derivatives, and you often want to find the absolutes of stuff. When are we going to make the most profit? When are we going to have the least spreading of whatever disease or virus? So first, you got to define your domain, find out what's in your domain. We've been doing that since Algebra 1. Find the derivative and find all those places where the derivative is 0 or undefined. Why? Because those are critical points. That's where it might be a maximum. Does it have to be a maximum? No. These are maximums, but this little wiggle here, or this little wiggle there, it could have just been an inflection point. It doesn't have to be the max or the min. And then we're going to do the T-chart thing that Nick said to do. And we're going to have the end points. And then all critical points that we've identified. And for this one, to find what is the absolute value of the function, do we use the function or the derivative?
Function.
The original function. The original function, we would plug those values in. And then you look in the little chart and be like, wow, which number is biggest? Which number is smallest? Crazy?
Is it the word extreme is another word for the maximum? Absolute.
Yeah, so, okay. Extrema, yay Greeks, they pluralize things with an A. That means any extreme. It could be a high or a low. So, yeah, there's that. And then if I'm asking absolute extrema, not who's the locally fastest swimmer, but who's the globally fastest. And they use the word global and absolute interchangeably. I don't recall if there's another, relative. Local and relative. Relative to the rest of you, I'm kind of short. Relative to the rest of you, I'm distinctly older. I am the local extreme in age, but not in the building. In this room, yes, but not in the building. Honest, I'm not. Okay. So for this problem on this domain, which one is open and one is closed, what's the absolute and absolute max and absolute min? I agree.
Oh,
I know, me too. Not really.
A keys.
So someone in here already did the derivative for us for this one. Multiply by the power, lower the power. So the derivative is 2/3 over x to the 1/3. It's not 0 anywhere, but the derivative is undefined at x equals 0. I have one critical point. Doing what Nick said, I'm gonna make my table of values with my endpoints, -1 and 8, and the critical point. I put -1 in there even though it's not defined there, because I need to know what if the highest or the lowest is that endpoint. And we knew what the graph looks like. What if it went like this and my absolute maximum was over there? And I wouldn't have an absolute maximum. But as it's drawn, or as it was picked, it's really doing this. But I do need to plug in that endpoint even though it's not included. And for myself, to make sure that I remember to say, if that's the highest or the lowest, I need to throw it out. I'm gonna circle this x to be like, it's a thing to be concerned about. -1 squared became +1, +1 to the 1/3. And yeah,
It's like a point of inflection, do you put it into the
so this is a point of inflection.
like the one where like the slope stays the same?
Anything that's a critical point goes in here, yes. So, so I put my ends and my one critical point, and mathematically, guys, doing x 8 to the 2/3, make it smaller first. 8 to the 1/3 is 2, then 2 squared is 4, versus doing 8 squared, which is 64, and knowing the cubed root. That might be hard. So absolute max is 4. Where does the absolute maximum happen? At x equals 8. The absolute min is 0. And where does it happen? It happens at x equals 0. This guy, is he a local maximum? No, because the x value is not included. Issues, comments, questions?
To find a critical point, we either set it to 0 or 9. We run 5, but we never like set this to 0.
Okay, well, if I set this to 0, looking at the fraction, when does 2 over something equal 0? 2 never equals 0. So now let's look at the denominator itself. So where is it undefined? When x is 0. Massimo, did you have a question? Okay. And it's a teeny bit different. With a calculator, try this one. Ethan, what's the process?
You start by finding that derivative,
Because we are looking for,
the critical points,
okay? So there's my derivative. How do I find the critical points?
set the derivative to 0, and find where it's 0 or undefined.
Okay, where is it undefined?
It's not.
It's not. Okay, what do I do with that now?
You make a table
Table?
with the critical points. And then you plug them into the original equation.
I'm missing something else. Something else I need to put in the table. The endpoints.
Points, yeah. Won't there never be, since it's like open, won't there not be an extreme value on?
On the last one we did, I had an absolute max there. That guy would have been a local, but he was open. But I can have absolutes. I don't know if you came in before or after this, but we can have maximums at the end and an absolute in the middle, or like all kinds
There
of.
can't be an absolute on the end if it's open, right?
Correct.
Okay, that's what I was asking.
Yes. But I still need to check.
Yeah.
Okay, and again, Eitan, am I plugging these numbers in, these x values into the function or into the derivative?
Function.
The function. Okay, so this looks like 5, -1 + 2 + 4. And, okay, so this is calculator to do these. And I don't remember their values. And I don't have it. Anyone have a calculator? Give me numbers. But plugging in the 327 minus 6 is 20. Sophie, what'd you get?
I just got my calculator.
Okay. So
Roughly, in the first one, roughly 2.911. Or wait, that actually might be the second.
well, I can figure it out this way. Just plugging in 0, negative, plugging in. So, looking at the numbers, the y values that you get in there, one of them is a local, and one, like, there is no absolute max because we don't have that value included. The homework is super, super simple. It's like, look at the pretty picture, what's the high, what's the low, if it exists. Day 27. Bye.